Hi, this is OXDF, and I'm looking at Advent of Code Day 7. Due to a weird combination of jet lag, weird sleep times, and weird time zones, I was actually awake when this went live today. So I tried to solve it as fast as I could to see if I could be competitive. Um, Quick spoiler, the answer was no. I finished the first part in 6 minutes, only to then later check and see that all the winning times were like under 2 minutes. So you got to be really fast to beat some of these folks who do this stuff. So, but because I was rushing through trying to do it fast, I did record, but it was not a watchable video. So we're just gonna go back and do it now. Day 7, Trench of Whales. Um, there's a lot of story here. The real answer is they're going to give me a list of numbers here. There's the position of some crabs along a horizontal axis, um, and basically they want to know if they want all the crabs to move to the same spot on the line. What's the sum of what's the shortest distance that all the crabs can move to get to that spot? So in this example, the answer is 2. And so, for the six to move from 16 to 2 costs 14, to move from 1 to 2 costs 1, 2 to 2 costs 0, and then you sum all that up, you get 37. So you can calculate that, presumably from infinity to negative infinity to infinity, and find the minimum. Now, if you think about it, it makes no sense. The minimum has to be somewhere between, in this case, 16 and 0, right? It can't, um, going to 17 and 18 would just make, as you step out away from that, everything's going to get further. Um, and there's probably a mathematical proof for that I could, sure, you could show and write down. I'm just going to take that as fact, so that we want to just look between the minimum and the maximum. And so, yeah, let's give that a shot. Um, so I'm going to use my notes here. I'm trying to make sure, I want to make sure I showed the different parts. So um, for part 1, um, basically I got my list of numbers here, right? So I'm going to open up I'm open up arg1, read it in. I'm going to read it all in. I should do it correctly here. Let's catch an error that would have come later. Um, Split on comma, and there. Okay, so I'm going to read in my input. I'm going to split on comma. I'm going to then put the integer function onto each item in that list, and then I will create a list out of it to get my nums. So, part 1. Now that you got me worried, let's Python -i day7.py and o7 example. What does nums look like? Oops, not sums, nums. Okay, that looks like what I want. So if I think about this, what I can do for each, if I have some position, we'll call it, so I'm going to loop over for position in, and I can do min, nums, comma, max, nums, +1. My Python loop over all of them. I could probably even get rid of the endpoints, but we'll just keep it there for now. That seems fine. For each position, I want to calculate the total distance traveled. So I'm going to do, I can start off with, okay, so what are all my points? N for N in nums. This is going to give me a list of all of the starting positions. But what I don't want the starting positions. I want to know the absolute value of N minus position. So now this will give me a list of all of the distances traveled to get to this position. So I should be able to just add sum around here. And now I've got um, this will for each position in the possible solutions, I will find the total distance traveled. And I actually just want the minimum of that, so I can do this in one line. We can do so we can do sums equals, let's do it this way. Sums equals, now we'll make this into an array. So we'll put a list. So end there, and so this will be for position in this. At delete that loop. So basically, this will give me the distances, all the distances. And so what I want for print, typing is hard this early in the morning. Part 1, min. Right, and so that is it's a very brute forcey way to look at that, but let's That does not look right. What am I doing wrong here? Okay. Let's see. If we do sums here, yeah, that I okay. I see. I'm not doing it. I'm doing it for position in that. I mean to do it in position of range there. There we go. That's a silly typo. No, it looks better. If I look at sums, I get a list there, and 37 comes at position 2. That matches up with the answer that I was expecting. Um, 37, 2. Um, so let's go back here, and we can apply that to my puzzle input. And it takes a second, and it gives an answer, and that's the right answer. So that works fine here. Part one. That. Um, so if we go back here and look again, part two is now going to say, okay, the cost is, and I'm not understanding the cost right. The cost is different. It's not actually one per spot, but it move. If you move one spot, it costs one. But if you then move two, it costs two more. So that's a total of three. If you move three steps, it costs six. One, two, three, etc. And so basically, I'm just changing the cost and recalculating. And my first my first thought was, I'm sure there's a math way to solve this. Like I'm sure there's a simplified math way to solve this, but it's early. I'm trying to go as fast as I can, so I'm just going to write a function that like does cost of x, and I'm going to return. This is very inefficient. If I thought about it for even just 2 minutes, I would have come up with a better answer. But um, sum of x for x in range. Oh, that's bad use there. I for I in range x. Actually, it's going to be I plus 1. So if x is 3, then range of 3 will return 0, 1, and 2, and I want to sum up 1, 2, and 3. So I'm going to get 0, 1, and 2, and I'm going to add 1 to them, and I'm just going to sum them all up, and I'm going to return that. And for small numbers, that works quick. So then I can come down here and say, grab this, yank, paste, and we'll make this sums 2 equals, and I'm no longer going to do the absolute. I'm going to do no longer just doing absolute value. I'm going to do cost, absolute value for position there, and that's it. So I'm just changing it from before I was summing up. I was summing across. This sum was looking across all the costs, and the cost was just the absolute value. Now it's cost of absolute value difference. So, and I thought, oh, this will work. So you come back here and you do example, and it works. Oops, it's not work. Let's see. Part two, min of sums. Two. Yeah, let's try that again. And it works quickly. Come back here and say, oh, is 168 the right answer? And 168 is the right answer. But when you try to apply this to something that's actually pretty large, which is puzzle input, it's part one okay, but then it just hangs. And I let this run for a couple minutes before I went, oh, this is not the answer, and I start trying to work. Now, first thing I can do to like kind of fix this is from func tools import LRU cache, and I can come here and I can put LRU cache this decorator on the function. And what this is going to do basically is if I need to calculate the cost of 10, every time I calculate cost of 10, it's going to have the same answer. And so if I, let's assume I'm calculating the cost of 1,000,000. Like if I'm getting some big numbers in here, this actually could take a minute to run this loop. And if I'm running it a lot of times, the time's going to add up, and that's what's happening to me here. But I don't need to calculate the cost of 10 more than once because it's always going to be the same. And so if I put this decorator on here, I was looking it up in here, and I could even add some tuning to it as well. But if I put this decorator on here, it's basically going to say, I want just store in memory what every time I call this function, store the result in memory. And if I call the same function again, I can know I just treat it. It's going to return the same thing. So just return the same thing. Don't bother doing the loop again. And once I do that, I can run this, and then the answer. I was hoping it was gonna be very quick, and the answer really it wasn't. But it was quick enough that when I was going, oh shoot, I'm gonna have to give up on this, and I went and started working on it. But I left it running. It actually did return an answer, and this is how I eventually got a solve. So I'm actually gonna pause the video here and see how long this takes to run. I'm kind of curious myself, and then I'll come back and show the actual reasonable way to solve this problem. All right, and so that took about 4.5 minutes, which it solves the problem, but it doesn't. It's not great, and it's again there's a much simpler solution. So let's see. I'm gonna go. Uh, let's just open up. So the mathematical proof here. This is a simple one. Probably should have come to this faster, but I want to find this sum, right? So sum is equal to 1 plus 2 plus 3 plus dot 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 plus uh, n minus 2 plus n minus 1 plus like that. There's gonna be a simpler way. There's a simpler way to figure this out. And so my favorite way to always think about this one is to have two of them like this. And so the second one, we're just gonna put the terms. Let's see, line. We're just gonna put the terms in backwards. So we'll put n here plus n minus 1 spacing plus n minus 2 plus dot 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 plus space this out so it looks nice and easy to follow. I know not everyone here loves math, and so this will be I'm just going down 3 plus 2 plus 1. Okay, and what we're going to do is we're going to add these two things together, and so what we're going to get is 2s plus or 2s equals, and this first group right here is going to be 1 plus n. And the second group is going to be 2 plus n minus 1, which is just going to be 1 plus n. And this third group is going to be 3 minus 2 plus n, which is going to be 1 plus n. You can see plus dot 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 plus each of these is going to be n plus 1. And how many n plus 1s are we going to have? Well, we're going to have there's n items in being added together, so there's going to be n of these things here. So we're going to have n times n plus 1. And now if we just divide both sides of this equation by 2, s is equal to n times n plus hard 1 over 2. So that's there's other ways that you can think about this, but that to me is always the kind of the cleanest way to show that. You can also just think about it. So we tried, if we think about 5, 1 plus 2 plus 3 plus 4 plus 5 is 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. If we put 5 in here, we get 5 times 6 is 30, divided by 2 is 15. So that works. So with that in mind, we don't need this function anymore, or we can, well, I don't know. Let's see. Put this. We'll still leave it as a function just because if we have it working, I wouldn't actually make this a function if I was starting from scratch, but we would just return x times x plus 1 divided by 2. And now, when I run that same function, I'm going to run very fast. So one second, and I get the same answer. Up here and clean this up a little bit, and put that there, and that would solve it. But so this is one of those ones where just knowing one of these little math things of like how do I solve the sum of the first n numbers, just makes it so much faster. So and that does give me 916, 389, 45. That was 916, 389, 45. So that was the answer. So I'm gonna wrap that up for today. Thanks for sticking with me till the end, and talk to you next time.